Hello, space explorers! Today we're going to dive into one of the most exciting and powerful phenomena in the universe, starbursts, or as scientists call them, supernovae. These are incredible events that can not only dazzle the entire galaxy with their light, but also play a key role in the evolution of the universe. Let's understand what supernovae are and what role they play in the cosmos. A supernova is a powerful explosion of a star at the end of its life cycle. Such explosions occur when a massive star burns up all its nuclear fuel reserves and can no longer sustain itself. Gravity begins to squeeze the star, and at one point its core collapses, resulting in a giant explosion. At this point, the star releases more energy than our Sun does in its entire lifetime. There are two main types of supernovae. The first type occurs when a massive star reaches the end of its existence and collapses under its own gravity. The second type happens in double systems when one of the stars, a white dwarf, gradually absorbs the matter of its companion star until it reaches a critical mass and explodes. But supernovae aren't just flashy cosmic shows. Their role is much more important. First, it is during supernovae that heavy elements such as gold, silver, and uranium are formed. These elements are then scattered through space and become the building blocks for new stars, planets, and even life. Yes, all the heavy elements we know on Earth, including the ones our bodies are made of, were once created in the interior of dying stars. Secondly, supernovae play an important role in spreading these elements across galaxies. The explosive force of a supernova ejects stellar material into space at tremendous speed, helping to form new star systems, as well as initiating star formation processes in other parts of the galaxy. Finally, supernovae are not only a source of new elements, but also a catalyst for the formation of black holes and neutron stars. After a star explodes, its remnants can become one of these exotic cosmic objects that play a key role in the evolution of galaxies. So supernovae aren't just destruction, they're also an act of creation that continues to shape our cosmos. Want to learn more about the mysteries of the universe? Subscribe to our channel, give us a like, and write in the comments what space topics interest you. Hello, space lovers! Today we are going to talk about what is probably one of the most mysterious and frightening questions in the universe. What happens if you fall into a black hole? This cosmic object has long stirred the minds of scientists and sci-fi fans because black holes violate all the usual laws of physics. How they work and what awaits you if you find yourself too close to one of them, we will tell you right now. Let's start by understanding what a black hole is. A black hole is an object with such strong gravity that nothing, not even light, can leave it. These giant matter eaters are formed when a star tens of times the size of the Sun runs out of fuel and collapses under its own gravity. At that point, there is a point where time and space cease to exist as we understand them. This is the so-called singularity. But before you get to the singularity, there is another important milestone on your way, the event horizon. This is a kind of point of no return. Once you've crossed the event horizon, there's no going back. No engine or technology can save you. The black hole will be your destiny. Now let's imagine that you decide to get close to a black hole. In the first stages, depending on the size of the hole, you may not notice anything at all. For example, if you find yourself near a supermassive black hole, which is at the center of galaxies, the gravitational effect on you will be relatively weak. But the closer you get to the event horizon, the stranger things will start to happen. The gravitational pull of a black hole stretches you into a long and thin shape. Scientists call this phenomenon spaghettification. This happens because of so-called tidal forces. Imagine that your feet are closer to the black hole than your head. That means gravity is acting harder on your feet. At first you'll feel a slight stretch, as if you're stretching after sitting for a long time, but the closer you get to the event horizon, the stronger this stretch will be, until you literally turn into spaghetti. You'll be stretched to the point where the human body can't take it. Now imagine someone watching you from a safe distance. To them, everything will look completely different. As you get closer to the event horizon, you'll start to slow down. The closer you get to the black hole, the slower your time flows to the outside observer. Eventually, you will freeze in time, right at the event horizon, and never completely disappear. This is because the light coming from you will redden and grow fainter and fainter until it disappears completely. To an outside observer, you will never cross the event horizon, although in fact you will have been inside for a long time. But what happens to you after you cross the event horizon? To be honest, scientists don't know for sure yet. It's one of the great mysteries of modern physics. One theory says that inside a black hole, the laws of physics as we know them no longer apply. Space and time are flipped and all your information and mass is added to the singularity, a point of infinite density. But there is another hypothesis. Some scientists believe that a black hole can be a portal to another dimension or even to another part of the universe. This idea was developed by many science fiction writers and even physicists based on the theory of wormholes. If such a wormhole existed, you could find yourself in a completely different place in space or even in another universe. Another important question that worries scientists: what happens to information that falls into a black hole? According to the laws of quantum mechanics, information cannot be destroyed. But if everything that goes into a black hole disappears in the singularity, what about that information? This question has given rise to the so-called black hole paradox. Some scientists speculate that information may persist at the event horizon, creating a kind of holographic imprint of what happened inside. This is one of the most debated topics in modern physics, and so far, we don't have a definitive answer. Modern scientists continue to study black holes using telescopes such as the Event Horizon Telescope, which in 2019 took the first image of a black hole's shadow. This was a groundbreaking discovery that gave us a real insight into what this cosmic object looks like. It is likely that in the future, black hole research will help us further understand the laws of the universe and the nature of space-time. The questions that arise before us are so big that their solution could overturn our understanding of physics. So, what happens if you fall into a black hole? At best, you'll turn into spaghetti and disappear over the event horizon. At worst, you'll cross the frontier of science and encounter the strangest laws of the universe that we can't even imagine. But black holes continue to inspire scientists and sci-fi fans with new ideas. They remain one of the greatest mysteries of the cosmos, and perhaps someday we will learn all their secrets. What do you think would happen inside a black hole? Write your theories in the comments, and don't forget to subscribe to the channel if you want to learn more about the mysteries of the universe. Hello, space enthusiasts! Today we're going to dive into one of the most fascinating and understudied topics in modern astrophysics: quark stars. These objects are potentially on the edge of the physical laws we know, and studying them can reveal many mysteries about how matter works. Quark stars, if they really exist, could be a real scientific sensation, as they represent matter in extreme states that scientists know little about so far. Let's understand how quark stars arise, how they differ from other stars, and what prospects for studying these objects await us in the future. What are quarks and quark matter? To understand what quark stars are, we first need to understand what quarks are. Quarks are the elementary particles that make up protons and neutrons. Quarks, along with leptons, form the basis of elementary particles, and there are known to be 6 types of quarks: top, bottom, strange, charmed, and true. Under normal circumstances, quarks do not exist in a free state. They combine to form more stable particles. However, according to theory, if matter is subjected to enormous pressure and temperature, as in the nuclei of neutron stars, quarks can exist in a free state and form what is known as quark matter. Neutron stars and quark stars, what is the difference? Quark stars are often seen as a possible evolutionary stage of neutron stars. After a massive star exhausts its fuel and its core collapses, what remains is something called a neutron star, an object of incredible density where protons and neutrons are literally squeezed together. But in some cases, the pressure and temperature can be so high that the neutrons and protons start to decay into individual quarks. The result is an even denser state of matter, a quark star. That is, in fact, quark stars can be a transitional link between neutron stars and black holes. Origin and conditions for the formation of quark stars. The question arises, under what conditions can quark stars form? Scientists believe that at certain masses and pressures, neutron stars can enter the so-called quark state. For example, if the mass of a star is large enough, its core will continue to contract even after it becomes a neutron star. This process can create conditions for free quarks to appear, forming a quark star. Possible conditions for the formation of quark stars. The mass of the star must exceed 2.5 to 3 solar masses. The temperature and pressure in the core must be tens and hundreds of times higher than in the core of a neutron star. Features of quark stars. The theory of strange quarks. There is a hypothesis according to which quark stars may consist of so-called strange matter. It involves strange quarks that give the star unique properties. These stars can be unusually stable, and the strange matter could remain stable even as it cools. Such a star made up of strange quarks is called a strange star, and if so, quark stars could be the densest and most stable objects in the universe after black holes. Potential observable characteristics of quark stars. How to distinguish a quark star from a neutron star. This is one of the main challenges that astronomers and astrophysicists are working on. Some signs by which quark stars could be distinguished are: quark stars can be even more dense than neutron stars. A quark star could have a smaller radius for the same mass as a neutron star. Quark stars may emit radiation at frequencies other than the normal radio emission of neutron stars. Current research and experiments. Scientists continue to study quark matter in the laboratory through experiments at places like the Large Hadron Collider (CERN). Although it is impossible to recreate the conditions that exist in quark stars in the laboratory, scientists are trying to model the behavior of quarks at high temperatures and pressures. Gravitational waves as a way to detect quark stars. In the last decade, gravitational waves have become a new and powerful tool in the study of space. When neutron stars collide, they generate gravitational waves, and if one or both of them are quark stars, scientists could detect this by the unique characteristic of gravitational waves. Quark stars and dark matter. Some scientists have hypothesized that quark stars may play a role in unraveling the nature of dark matter. The strange matter supposedly existing in quark stars could explain some of the dark matter present in the universe. This is an interesting, albeit hypothetical, possibility that could open the way to a deeper understanding of the structure of the universe. The cosmological significance of quark stars. If quark stars do exist, it could mean that they were the first objects to form after the Big Bang. Quark stars could have formed shortly after the quarks and gluons closed up into the first protons and neutrons. Quark stars remain an enigma, and perhaps their study can turn our understanding of the universe upside down. Don't forget to subscribe to our channel so you don't miss new exciting videos. Your subscriptions and likes help us create more fun content. Thank you for watching. Particularly striking are the discoveries of objects whose existence contradicts our ideas about the formation of the universe. Astronomers find themselves in a surprisingly difficult position. As the James Webb Space Telescope continues to uncover one cosmic mystery after another, it is becoming clear that many of the theories that have guided scientists for decades may have been wrong. These findings call into question not only cosmological models, but also our understanding of the Big Bang. The Webb Telescope, with its unique infrared capabilities, has changed the way scientists look at the cosmos. Just look at the discovery of 6 mysterious galaxies that existed only 500 to 700 million years after the Big Bang. These galaxies contain an astonishing amount of matter, between 10 and 100 billion solar masses, which is amazing for such an early period of the universe. According to current theories, enough matter should not have existed at this time to form such massive galaxies. But it's not just the scale of the objects. Webb showed that our universe is much more complex and mysterious than we realized. Galaxies like these shouldn't have existed. Theories about how stars and galaxies formed after the Big Bang are now in question. Scientists are faced with having to rethink what we thought were the underlying principles of how cosmic structures formed. The question arises, how much will these discoveries shake up the scientific community? Some experts believe we are on the verge of a revolution in cosmology. This discovery could lead to revised theories about how early galaxies evolved, or even changes in our ideas about the Big Bang. Perhaps galaxies that are now perceived as impossible may turn out to be clues as to how the universe grew so quickly after the Big Bang. But how do these discoveries relate to our ideas about the origin of the cosmos? One hypothesis is that the density of matter in the early universe may have been much higher than thought. Another is that the process of star and galaxy formation was much faster and more intense than we thought. All of this points to the need to revise current models. When it comes to the deeper picture, however, even more questions arise. How confident are we that we know exactly how the Big Bang happened? Some scientists suggest that the Big Bang was only part of a much more complex process. For example, there is the Big Bang theory, which states that the universe was not born once, but goes through cycles of contraction and expansion. But what if our cosmos is not the only one? Surprisingly, there are hypotheses that objects, such as black holes, may be a link between parallel universes. In this context, the James Webb Telescope may play a role in unlocking not only the mysteries of our universe, but also speculations about the existence of other worlds. We are thus on the cusp of new discoveries that could change our understanding of the cosmos. The Big Bang, black holes, the formation of galaxies, all of these questions seem far more complex and profound today than ever before. Perhaps it is these impossible galaxies that will be the key to understanding how it all began. But no matter what answers await us, one thing is clear: the universe is full of mysteries that are only beginning to unfold before us. However, the mysteries that the James Webb Telescope reveals are just the tip of the iceberg. With each new image, scientists are faced with questions that previously seemed fantastic. For example, how could such massive galaxies have appeared so soon after the Big Bang? Could it be that our ideas about time and space need a complete overhaul? Or are there some unknown forces that govern the evolution of the cosmos? Another mystery remains the discovery of invisible objects, those that do not correspond to our ideas about stars or galaxies. Their existence calls many theories into question, and scientists still can't figure out what they are. They may be new forms of matter or energy that we have no idea about yet. The future of astronomy and cosmology looks more exciting than ever. With the new discoveries of the Webb Telescope, mankind has the opportunity to look even further into the past of the universe, uncover new mysteries, and perhaps change our understanding of cosmic processes forever. If you want to keep learning about the most advanced discoveries in space, give us a like and subscribe to the channel. Don't miss the next videos that may change your view of the universe.